Hello friends, let me welcome you all to my third video on the chapter electrochemistry, right? In the previous video, we discussed something about standard hydrogen electrode as reference electrode and the determination of standard electrode potentials of various electrodes by using standard hydrogen electrode as reference electrode, right? Imagine here, I have here different electrode systems, right? Lithium electrode, sodium electrode, magnesium, aluminium, zinc, iron, hydrogen electrode, and I have copper electrode, silver electrode, gold electrode, and fluorine. Is it not? I determined the standard electrode potentials of all these electrode systems by taking hydrogen electrode as reference electrode, and these are the values of these electrode systems. What I am doing here is I am going to arrange all these electrode systems in the increasing order of their electrode potential values. If I move from lithium to fluorine, standard electrode potential goes on increasing. Look at this, it is minus 3.05. It is very, very low. Lowest standard electrode potential as far as lithium electrode is concerned. Highest standard electrode potential is plus 2.87 in the case of fluorine. So what is the advantage of this arrangement? What is the advantage of this arrangement? Here I have arranged various electrode systems in the increasing order of their standard electrode potentials, and that series is called as electrochemical series. I can make some conclusions on the basis of this electrochemical series. Because of that, I have drawn this particular, the electrochemical series here. And remember, if I move from lithium to fluorine, standard electrode potential increases. If I say standard electrode potential increases, it means that tendency to gain electrons increases. That means fluorine has got highest tendency to undergo reduction. Means fluorine has got highest tendency of accepting electrons. That's why its reduction potential is very, very high. Lithium has got lowest tendency of accepting electrons. Lithium has got lowest tendency of accepting electrons. And its standard reduction potential is least among these electrode systems. If I say standard electrode potential is high antandre, if SRP value is high, tendency to undergo reduction is high. That is, tendency to undergo reduction is very, very high. Among these electrode systems, which has got highest tendency to undergo reduction antandre, fluorine has got highest tendency to undergo reduction, and that means fluorine readily accepts electrons and becomes F minus. And because of that, what we say generally, anything that undergoes reduction easily is a very good oxidizing agent. Anything that undergoes reduction easily, very good oxidizing agent. Therefore, if I move from lithium to fluorine, if I move from lithium to fluorine in the electrochemical series, what we call it as oxidizing tendency increases. Oxidizing tendency increases. That if I move from lithium to fluorine, oxidizing tendency of element increases. Oxidizing tendency increases because anything that undergoes reduction easily is a very good oxidizing agent. Fluorine undergoes reduction easily, therefore it's very good oxidizing agent. Lithium ion that does not undergo oxidation, that does not undergo reduction easily. Lithium ion does not undergo reduction easily because its SRP value is very, very less. Tendency of gaining electrons in the case of lithium ion Li plus is very, very less. Therefore, it is weakest oxidizing agent and fluorine is strongest oxidizing agent. And of course, in these electrode reactions, whatever the ions and elements I am writing on the left side as a reactant, they are all oxidizing agents. Li plus, Na plus, Mg plus 2, Al3 plus, oxidizing agents. Product fluorine has got highest tendency to undergo reduction. Therefore, it is strongest oxidizing agent. And remember, if I take this F minus, which is on the product side, F minus, it has got lowest tendency. In the reverse reaction, right side only, ions are getting electrons and become Li plus, it is reduction. Reverse is oxidation, is it not? Reverse is oxidation. Illi, F2 has got highest tendency to undergo reduction. It means what? The reverse is not possible. Means F minus has got least tendency to undergo oxidation. But in the case of lithium, Li plus has got least tendency to undergo reduction. As I said, Li plus has got least tendency to undergo reduction. Therefore, it is weakest oxidizing agent. But in the reverse process, Li lithium atom has got highest tendency to undergo oxidation. ಹೌದಾ? ಇಲ್ಲಿ ರಿಡಕ್ಷನ್ ಪೊಟೆನ್ಷಿಯಲ್ ಲೋ ಅಂತಂದ್ರೆ ಟೆಂಡೆನ್ಸಿ ಟು ಅಂಡರ್ಗೋ ರಿಡಕ್ಷನ್ is less, but reverse is very very high. That means reverse tendency to undergo reduction is less means tendency to undergo oxidation is high. Reverse process is oxidation. Forward process reduction andre backward ಏನು oxidation means lithium has got highest tendency to undergo oxidation. And of course what I said, anything that undergoes oxidation easily is a very good reducing agent. Anything that undergoes oxidation easily is a very good reducing agent. Therefore, if reactants are oxidizing agents, and of course products will be reducing agents. The products ಎಲ್ಲ ಬಂದಿಲ್ಲ ಈ ರಿಯಾಕ್ಷನ್ ಅಲ್ಲಿ ಇವೆಲ್ಲವೂ ಕೂಡ ಏನು reducing agents. Among these, lithium, sodium, magnesium and fluoride, from here to here ಏನಾಗುತ್ತೆ, reducing property decreases. That is from lithium to fluoride. This is from Li+2 to F2 ಇದು. From lithium to fluoride ಏನಾಗುತ್ತೆ, reducing power decreases. Reducing tendency ಏನಾಗುತ್ತೆ, decrease ಆಗುತ್ತೆ. From Li+ to F2 ಏನಾಗುತ್ತೆ, oxidizing tendency increases, but reducing power, reducing tendency decreases. And that's why lithium is a powerful reducing agent. Fluoride is a weakest reducing agent. Fluoride is a weakest reducing agent. Lithium is a powerful reducing agent. Hagagi, this is two important conclusions that we can make. Okay, the one with high SRP, the one with high SRP is a very good oxidizing agent. The one with the low SRP is very good reducing agent. And of course, apart from that, I can make one more decision. Look at this. In the electrochemical series, here we have hydrogen, right? For hydrogen electrode, SRP value is, yes, it is very very less. Howdalva? Here in the case of hydrogen electrode, SRP value is 0 anta ide. Howda? Look at the metals above hydrogen. Look at the metals above hydrogen. Their standard electrode potentials are less than 0. Look at the metals below hydrogen. Their standard electrode potentials are more than 0. Or greater than 0. Howdalva? And if I say that is aluminum and hydrogen, if I connect aluminum electrode and hydrogen electrode, if I connect aluminum electrode and hydrogen electrode, out of aluminum and hydrogen, which undergoes reduction easily? X plus, because its SRP is 0, greater than -1.67. Therefore, X plus undergoes reduction easily. Therefore, hydrogen gas is liberated. Again, if I connect anything, magnesium and, yes, it is hydrogen electrode. If I connect magnesium and hydrogen electrode, H plus has got high tendency to undergo reduction, and with magnesium also hydrogen gas is liberated. Therefore, the metals above hydrogen in electrochemical series, lithium, sodium, magnesium, aluminum, zinc and iron, these SRP values of these metals will be less than 0. Therefore, these metals displace hydrogen gas when they react with, yes, it is dilute acids. These metals, yes, it is react with dilute acids to liberate hydrogen gas. Whereas if I connect hydrogen and silver and if I connect hydrogen and silver electrodes, out of H plus and Ag plus, which has got high SRP, Ag plus, that is plus 0.80. This is greater than 0. Hagagi, out of H plus and Ag plus, which undergoes reduction? Ag plus undergoes reduction. Therefore, silver readily undergoes reduction. Therefore, reduction of H plus is not possible. And therefore, these metals like copper, silver, gold, they do not displace hydrogen from dilute acids. They do not displace hydrogen from dilute acids because they are lying below hydrogen. Their SRP values are greater than H plus. Therefore, they are reducing. They do not displace hydrogen from dilute acids. And of course, because of that, in some competitive exams, the questions based on this you can expect. For example, Zn plus 2HCl gives H2 plus ZnCl2 ಅಂತ ಇಟ್ಕೊಳ್ಳಿ. ಇದೊಂದು ರಿಯಾಕ್ಷನ್. Cu plus 2HCl gives H2 plus CuCl2 ಅಂತ ಬರೆದ್ರೆ, out of these two which is possible? Only this one is possible. This is not possible because copper does not displace hydrogen from dilute acids, because copper is lying below hydrogen in electrochemical series, that does not displace hydrogen, whereas zinc lying above in electrochemical series, lying above hydrogen in electrochemical series. Therefore, zinc displaces hydrogen from dilute acids. ಈ ತರ ಕೆಲವು ಪ್ರಶ್ನೆಗಳನ್ನ ಕೇಳ್ತಾರೆ. ಜೊತೆಗೆ ಈ ಡಿಸಿಷನ್ಸ್ ಇದು ಕೂಡ ಇನ್ಆರ್ಗಾನಿಕ್ ಕೆಮಿಸ್ಟ್ರಿ ಕೂಡ ನಿಮಗೆ ಹೆಲ್ಪ್ ಆಗುತ್ತೆ. ಇದೇ ಕಾನ್ಸೆಪ್ಟ್ ಅನ್ನ ಪಿ ಬ್ಲಾಕ್ ಎಲಿಮೆಂಟ್ಸ್ ಅಲ್ಲಿ ನೀವು ಬಳಸ್ಕೊಂಡ್ಬಿಟ್ಟು ನೀವು ಈಕ್ವೇಷನ್ಸ್ ಅನ್ನ ಬರೀಬಹುದು. ಓಕೆನಾ? ಸೊ ದಿಸ್ ಇಸ್ ವಾಟ್ ವಿ ಕಾಲ್ ಇಟ್ ಆಸ್ Yes, it is electrochemical series. Apart from that, one more advantage of this electrochemical series, you can decide which is cathode and which is anode, and by making use of this particular electrochemical series. See, for example, if I connect magnesium and yes, it is sodium ಅಂತ ಇಟ್ಕೊಳ್ಳಿ, ಇವೆರಡು electrode systems ಅನ್ನ ಕನೆಕ್ಟ್ ಮಾಡ್ತೀನಿ ಅಂತ. ಆಗ ಔಟ್ ಆಫ್ ಸೋಡಿಯಂ ಅಂಡ್ ಮೆಗ್ನೀಷಿಯಂ ವಿಚ್ ಇಸ್ ಕ್ಯಾಥೋಡ್ ವಿಚ್ ಇಸ್ ಆನೋಡ್ ಅಂತ ಹೇಳಿದ್ರೆ ಏನ್ ಹೇಳ್ತೀರಾ? One with high SRP minus 2.37 is greater than minus 2.73. ಹಾಗಾಗಿ the one with high SRP is acts as a cathode, one with low SRP acts as a anode. ಈಗ ಅಕಸ್ಮಾತ್ ನೀವು ಮೆಗ್ನೀಷಿಯಂ ಮತ್ತೆ ಲಿಥಿಯಂ ಸೋಡಿಯಂ ಮತ್ತೆ ಲಿಥಿಯಂ ಕನೆಕ್ಟ್ ಮಾಡಿದ್ರೆ sodium becomes cathode, lithium becomes anode, because SRP of sodium is greater than SRP of lithium. ಯಾವ ಎಲೆಕ್ಟ್ರೋಡ್ ಸಿಸ್ಟಮ್ಗೆ SRP ವ್ಯಾಲ್ಯೂ ಜಾಸ್ತಿ ಇರುತ್ತೆ ಅದು ಕ್ಯಾಥೋಡ್ ಆಗುತ್ತೆ, ಯಾವುದಕ್ಕೆ SRP ಕಡಿಮೆ ಇರುತ್ತೆ ಅದು ಆನೋಡ್ ಆಗುತ್ತೆ. ಫಾರ್ ಎಕ್ಸಾಂಪಲ್, ನೀವೇ ಡೇನಿಯಲ್ಸ್ ಅಲ್ಲಿ ಏನ್ ಮಾಡಿದ್ರಿ ಗೊತ್ತಾ? ಜಿಂಕ್ ಮತ್ತೆ ಕಾಪರ್ ಕನೆಕ್ಟ್ ಮಾಡಿದ್ರು, ಹೌದಾ? ಜಿಂಕ್ ಮತ್ತೆ ಕಾಪರ್ ಕನೆಕ್ಟ್ ಮಾಡಿದಾಗ ಯಾವ್ದು ಕ್ಯಾಥೋಡ್ ಆಗಿತ್ತು? ಕಾಪರ್ ಕ್ಯಾಥೋಡ್ ಆಗಿತ್ತು, ಬಿಕಾಸ್ ಇಟ್ಸ್ SRP ವ್ಯಾಲ್ಯೂಸ್ ಇಸ್ ಹೈ ಕಂಪೇರ್ಡ್ ಟು ಜಿಂಕ್, ಹೌದಾ? ಅದೇ ನಾನು ಹೇಳಿದ್ದೆ, ವೆನ್ ಜಿಂಕ್ ಅಂಡ್ ಎಸ್ ಇಟ್ ಇಸ್ ಅಲ್ಯೂಮಿನಿಯಂ ಆರ್ ಕನೆಕ್ಟೆಡ್, ಜಿಂಕ್ ಅಲ್ಯೂಮಿನಿಯಂ ಕನೆಕ್ಟ್ ಮಾಡಿದಾಗ ಯಾವ್ದು ಕ್ಯಾಥೋಡ್ ಆಗುತ್ತೆ? ಜಿಂಕ್ ಕ್ಯಾಥೋಡ್ ಆಗುತ್ತೆ. ಯಾಕೆ ಹೇಳಿ? SRP of zinc is more compared to SRP of aluminum. ಅದೇ ಕಾಪರ್ ಮತ್ತೆ ಸಿಲ್ವರ್ ಕನೆಕ್ಟ್ ಮಾಡಿದ್ರೆ ಏನಾಗುತ್ತೆ? ಸಿಲ್ವರ್ is has got high SRP compared to copper. ಅಂದಾಗ silver is acting like a cathode, copper is acting like a yes it is anode. ಇಲ್ಲ ಅಂದ್ರೆ ಎಲೆಕ್ಟ್ರೋಕೆಮಿಕಲ್ ಸೀರೀಸ್ ಅಲ್ಲಿ ಯಾವ್ದಾದ್ರೂ ಎಲೆಕ್ಟ್ರೋಡ್ ಸಿಸ್ಟಮ್ಸ್ ಅನ್ನ ಕನೆಕ್ಟ್ ಮಾಡಿದಾಗ ಕೆಳಗಡೆ ಬರೋದು ಕ್ಯಾಥೋಡ್ ಆಗುತ್ತೆ, ಮೇಲ್ಗಡೆ ಬರೋದು ಆನೋಡ್ ಆಗುತ್ತೆ, ಅಷ್ಟೇನೆ, ಹೌದಾ? ನೀವೇನ್ ಮಾಡಿದ್ರಿ ಗೊತ್ತಾ? ಹೈಡ್ರೋಜನ್ ಮತ್ತೆ ಕಾಪರ್ ಕನೆಕ್ಟ್ ಮಾಡಿ SRP ಡಿಸೈಡ್ ಮಾಡಿದ್ರಲ್ಲ, ಅವಾಗ ಯಾವ್ದು ಕ್ಯಾಥೋಡ್ ಆಗಿತ್ತು? ಕಾಪರ್ ಕ್ಯಾಥೋಡ್ ಆಗಿತ್ತು, ಹೈಡ್ರೋಜನ್ ಆನೋಡ್ ಆಗಿತ್ತು. ಅದೇ ಜಿಂಕ್ ಮತ್ತೆ ಹೈಡ್ರೋಜನ್ ಕಲೆಕ್ಟ್ ಮಾಡಿದಾಗ ಹೈಡ್ರೋಜನ್ ಕ್ಯಾಥೋಡ್ ಆಗಿತ್ತು, ಜಿಂಕ್ ಆನೋಡ್ ಆಗಿತ್ತು. ಈ ತರ ಡಿಸಿಷನ್ಸ್ ಅನ್ನ ನೀವೇನ್ ಮಾಡಬಹುದು, ತಗೋಬಹುದು ಆನ್ ದ ಬೇಸಿಸ್ ಆಫ್ ಎಸ್ ಇಟ್ ಈಸ್ ಎಲೆಕ್ಟ್ರೋಡ್ ಪೊಟೆನ್ಶಿಯಲ್ ವ್ಯಾಲ್ಯೂಸ್ ಅಥವಾ SRP ವ್ಯಾಲ್ಯೂಸ್ ಅಥವಾ ಎಲೆಕ್ಟ್ರೋಕೆಮಿಕಲ್ ಸೀರೀಸ್ ಆಗ್ಬೋದಾ? ಅಪಾರ್ಟ್ ಫ್ರಮ್ ದಟ್, ಹಿಯರ್ ವಿ ಹ್ಯಾವ್ ಒನ್ ಸ್ಮಾಲ್ ಟಾಪಿಕ್ ದಟ್ ಈಸ್ ಇನ್ನರ್ಟ್ ಎಲೆಕ್ಟ್ರೋಡ್ಸ್ ಅಂತ ಇದೆ. And these are all the electrode systems where metal undergoes reaction. Whereas here, in the case of inert electrodes like platinum, gold, they do not take part in chemical reaction, but still they are very essential because they provide surface for the oxidation and reduction reactions. For example, in the case of hydrogen electrode, what we seen, that is hydrogen gas was taken on. Yes, it is in the case of standard hydrogen electrode. Hydrogen gas was absorbed over platinum. Here platinum was providing surface for hydrogen gas, but it doesn't take part in any chemical reaction. That's why platinum is inert electrode. Hagene, in the case of bromine electrode, that is platinum and it is bromine, that is liquid, yes, and of course Br minus, and of course this is aqueous medium. This is what we call bromine electrode. In bromine electrode, the reaction is Br2, that is half Br2 will take up one electron and becomes Br minus. This is a reduction reaction. Half of Br2 will take up one electron and becomes Br minus. This is a reaction where bromine will be absorbed over platinum, but platinum doesn't take part in chemical reaction. In hydrogen electrode, you had seen H plus will take up one electron and becomes half H2. This is a reaction in hydrogen electrode. They do not take part in chemical reaction, inert electrodes, but they provide surface for the oxidation and reduction reactions to take place. And this is what we call it as, yes, it is electrochemical series, and of course inert electrodes. Agboda? Now we'll go to the next topic. Yes. Next and very important discussion as far as your annual examination is concerned, that is Nernst equation. As you know that you determined standard electrode potentials of various electrode systems by taking standard hydrogen electrode as a reference, and that is only under standard conditions and at a temperature of 298 kelvins, under pressure of 1 bar, and under the concentration of 1 molar. But what about the standard electrode potentials at any temperature, concentration and pressure? How to determine standard electrode potential values of electrode systems at any temperature and at any concentration of ion? For that purpose, we make use of what we call it as Nernst equation. We have two equations. One, Nernst equation for electrode potential. Another is Nernst equation for cell potential. Yes. And look at this, for electrode reaction, that is M plus N plus N electrons, right? For this particular electrode reaction, that gives M, that is solid, and this is aqueous solution. This is what we call it as one electrode reaction ಅಂತ ಇಟ್ಕೊಳ್ಳಿ. Where M plus N undergoes its reduction and this is a product and this is a reactant. ಹೌದಾ? According to Nernst equation, that is electrode potential of metal electrode M is equal to standard electrode potential of that metal electrode S, and of course minus, that is RT divided by NF. Yes, it is log to the base E of, yes, it is molar concentration of product. Molar concentration of product of the reaction divided by molar concentration of ion reactant of the, yes, it is this is reactant. Molar concentration of product divided by molar concentration of reactant. Yes, M is a product, M plus N is a reactant. ಹೌದಾ? But here, as far as EM is concerned, this is electrode potential at any temperature and concentration. This is standard electrode potential. That is from electrochemical series. R is a gas constant, that is R is equal to 8.314 joules per Kelvin per mole. Yes, and of course T is a temperature in kelvins, right? T is a temperature in kelvins. So the F is a Faraday's constant, 96,500 coulombs. And of course, as far as molar concentration of metal, that is a solid, molar concentration of solid in chemical reactions will remain same. Therefore, this will be taken as 1 there. Yes, and therefore equation will take the form, that is EM is equal to, yes, E naught M minus, and of course RT divided by NF log to the base E of, yes, it is 1 divided by molar concentration of metal ion. 1 divided by molar concentration of metal ion, that is what we call it as Nernst equation for, yes, it is that is electrode reaction, that is electrode potential. Yes, now I can determine electrode potential of electrode system by change at any temperature and concentration. Or you can rewrite it as, that is EM is equal to, yes, E naught of M plus ಮಾಡ್ತೀನಿ ಈಗ ಮೈನಸ್ ಅನ್ನ ಪ್ಲಸ್ ಮಾಡಿದ್ರೆ RT divided by NF log to the base E of 1 by M ಏನಾಗುತ್ತೆ? Yes, it is concentration of metal ion. ಹೌದಾ? ನಾನು ಹೇಳ್ತಾ ಇದ್ದೆ, as temperature increases electrode potential increases, as concentration of ion increases electrode potential increases. ಹೌದಾನೆ? So this is what we call it as Nernst equation. Yes, it is for calculating, yes, it is electrode potential at any temperature and concentration. So now here I can have some alternate forms of this particular equation. Again, that is EM is equal to, yes, it is E naught of M plus, ಇಲ್ಲಿ log to the base E ಇದೆ, ಅದನ್ನು 10 ಮಾಡಿಬಿಟ್ಟು ಏನಾಗುತ್ತೆ? 2.303 RT divided by NF log to the base 10 of, yes, it is molar concentration of metal ion ಆಗುತ್ತೆ. Yes, ಏನು ಮಾಡಿದೆ ನಾನು? log to the base E ಅನ್ನ log to the base 10 ಮಾಡ್ಕೋಬೇಕಂದ್ರೆ 2.30 ಇಂದ ಮಲ್ಟಿಪ್ಲೈ ಮಾಡಬೇಕಾದ್ರೆ ಪ್ರಿನ್ಸಿಪಲ್ಸ್ ಆಫ್ ಲಾಗರಿಥಮ್ಸ್ ಅಲ್ಲಿ ಬರುತ್ತದು. ಓಕೆನಾ? ಈಗ ನೋಡಿ, this is what we call Nernst equation. ಹೌದಾ? And if I keep the temperature, that is 298 kelvins ಅನ್ನು ಹಾಕಿ, yes, ಆಮೇಲೆ R ವ್ಯಾಲ್ಯೂ ನಿಮಗೆ ಸಬ್ಸ್ಟಿಟ್ಯೂಟ್ ಮಾಡಿ 8.314 joules per Kelvin per mole. Yes, F ಅನ್ನ 96,500 coulombs ಹಾಕಿದ್ರೆ ಏನಾಗುತ್ತೆ ನೋಡಿ? equation will take a form, EM is equal to E naught of M plus 2.303 into 8.314 into 298 divided by N into 96,500. ಹೌದಾ? And of course log to the base 10 of molar concentration of metal ion. Yes, log to the base 10 of molar concentration of metal ion. Therefore, and that is EM is equal to E naught of M plus, ಇದೆಲ್ಲ ಸಿಂಪ್ಲಿಫೈ ಮಾಡಿದ್ರೆ you will get 0.059 divided by N. 2.303 into 8.314 into 298 divided by 96,500 ಮಾಡಿದ್ರೆ you are going to get 0.059 divided by N into log to the base 10 of, yes, it is concentration of metal ion. This is also another form of, yes, it is Nernst equation, but this is true only at 298 kelvins. This is true only at 298 kelvins. ಈ ಟೆಂಪರೇಚರ್ ಚೇಂಜ್ ಮಾಡಿದ್ರೆ ಈ ವ್ಯಾಲ್ಯೂ ಚೇಂಜ್ ಆಗುತ್ತೆ. ಹಾಗಾಗಿ this is the formula that you can use if the temperature is 298 Kelvin. Other than 298 kelvins, you go for this formula. Yes, so this is what we call it as Nernst equation for, yes, it is determining electrode potential. Yes, ಅರ್ಥ ಆಯ್ತು ಅನ್ಕೋತೀನಿ. ಆಗ್ಬೋದಾ? ಕೇಳ್ತಾರೆ, write Nernst equation and explain the terms in it ಅಂತ ಹೇಳಿ. ಇಷ್ಟು ಬರಿಬೇಕು. ಬರೆದ್ಬಿಟ್ಟು ಇದನ್ನ ಬರೀರಿ. ಬರೆದ್ಬಿಟ್ಟು EM ಅಂದ್ರೇನು, E0 M ಅಂದ್ರೇನು, F ಅಂದ್ರೇನು, R ಅಂದ್ರೇನು, T ಅಂದ್ರೇನು ಬರಿಬೇಕು. ದಟ್ ಈಸ್ R is gas constant, F is a Faraday's constant 96,500, T is the temperature in kelvins, yeah, and of course N is the charge of the ion. Nodi, number of electrons gained or lost. That is your N electrons are added. Athwa M is losing N electrons. Athwa charge of the metal ion. Adala N value. So that is what we call it as N here. Yes. Okay na. I'll write Nernst equation for zinc electrode, and yes, it is copper electrode. Is E of copper is equal to, that is equal to E0 of copper plus 2.303 RT by N badlagi 2, because in the case of copper, charge of copper is 2, and of course 2F log to the base 10 of, yes, it is concentration of copper plus 2. This is what we call it as Nernst equation for copper. Again, E of zinc is equal to, right, E0 of zinc plus 2.303 RT by 2F, because charge of zinc is plus 2, athwa number of electrons lost by zinc is 2. Hagagi N is equal to 2 here, and log to the base 10 of molar concentration of Zn plus 2. This is Nernst equation for, yes, it is zinc electrode. Yes. ಹಾಗೆ ನೀವು Nernst equation ಅನ್ನ ಬೇರೆ ಬೇರೆ ಎಲೆಕ್ಟ್ರೋಡ್ ಸಿಸ್ಟಮ್ಸ್ ಗೆ ಬರೀಬಹುದು. ಈಗ ಫಾರ್ ಎಕ್ಸಾಂಪಲ್ ಅಲ್ಯೂಮಿನಿಯಂ ಹೇಳಿದ್ರೆ, that is E of aluminum is equal to E0 of aluminum plus 2.303 by 3F. 3F ಯಾಕೆ ಬರ್ತದೆ? aluminum loses 3 electrons, ಅಥವಾ charge of aluminum is plus 3, ಅದಕ್ಕೆ 3F log to the base 10 of concentration of Al3 plus. This is what we call it as Nernst equation. Yes. ಅದೇ ಹೈಡ್ರೋಜನ್ ಬರೆದ್ರೆ E of hydrogen is equal to E0 of hydrogen plus 2.303 RT by F. ಯಾಕೆ ಹೇಳಿ? N is equal to 1, because charge of hydrogen is 1, and of course log to the base 10 of, yes, it is molar concentration of H plus. This is for hydrogen electrode. ಈ ತರ ನಾವು electrode systems ಗೆ Nernst equation ಅನ್ನ ಬರೀಬಹುದು. Yes. ಈಗ Nernst equation for cell potential, that is E of cell. And of course, as per your NCERT book, we need to obtain that cell potential for the Nernst equation for the cell potential by making use of Daniell cell. For Daniell cell, Zn plus Cu plus 2, right? And that gives what? Zn plus 2 plus Cu. And the reaction is reversible. This is what we call it as the reaction that is going on in Daniell cell. We have copper electrode, and yes, it is zinc electrode. According to, yes, it is our formula, that is E of cell is equal to E0 of cathode minus E0 of anode. Yes, E0 of cathode minus E0 of anode. This is what we call it as formula. Illi E of cell is equal to, that is E of cell is equal to E0 of copper minus, E of copper minus E of zinc. ಹೌದಲ್ವಾ? E of cell is equal to E of copper is equal to E of zinc, ಅಥವಾ E0 of cell is equal to E0 of copper minus E0 of zinc. ಈಗ ಬರಿ ಬರ್ತಾನೆ. E of cell is equal to E of cathode minus E of anode. Yes. ಅಥವಾ E0 of cell is equal to E0 of cathode minus E0 of anode. ಹೌದಲ್ವಾ? ಸೊ ಇದೆಲ್ಲ ನಮಗೆ ಗೊತ್ತಿರುವಂತ ವಿಚಾರ. ಎಸ್, ಹೌದಾನೆ? ಈಗ ನೋಡಿ, as far as E of cell is concerned, that's equal to, I write expression for copper, that is E0 of copper plus RT by NF log to the base of molar concentration of copper plus 2. ಹೌದಾ? ಸರಿ ಬರ್ತಾನೆ ಇದು. ನಾನೇನು ಬರ್ತೀನಿ ಈಗ? ಕಾಪರ್, I have written expression for electrode potential of copper. E of copper is equal to E0 of copper plus RT by N ಬದಲಾಗಿ ಏನು ಬರೀಬಹುದು ನೀವು ಬೇಕಾದ್ರೆ? 2F, because charge of copper is plus 2. Log to the base of copper, ಇಲ್ಲಿ RT ಬರೆದ್ರಿಂದ log to the base ಬರೀತೀನಿ. This is copper ಆಯ್ತು. Minus, that is ಇದು ಒಂದು E of copper ಆಯ್ತು. Yes, and minus E of zinc is equal to E0 of zinc plus RT by 2F. RT by 2F log to the base of, yes, it is molar concentration of zinc ions. ಹೌದಾ? ಈಗ ಏನ್ ಮಾಡ್ತೀನಿ ಅಂದ್ರೆ, E naught of copper minus E naught of zinc ಒಂದ್ ಕಡೆ ಬರ್ಕೊಂಬಿಡಿ. E naught of copper minus E naught of zinc ಈಕ್ವೇಷನ್ ಹೊರಗೆ ತಗೊಂಬಿಡಿ. ಹೌದಾ? ಮೈನಸ್ RT by 2F ಅನ್ನ ಕಾಮನ್ ತೆಗಿರಿ. ಮೈನಸ್ RT by 2F ಅನ್ನ ಕಾಮನ್ ತೆಗಿರಿ. ಎಸ್, ಇಲ್ಲಿ RT by 2F ಇದೆ, ಇಲ್ಲಿ RT by 2F ಇದೆ. ಹೌದಾ? ಕಾಮನ್ ತೆಗೆದ್ರೆ ಇಲ್ಲಿ ಮೈನಸ್ ಇರೋದ್ರಿಂದ ರೈಟ್, ದಟ್ ಈಸ್ log to the base E of S concentration of Zn plus 2 minus log to the base E of S, it is concentration of copper plus 2 ಆಗುತ್ತೆ. And if I write the symbol of the ion in square bracket, ಏನಂತ ಹೇಳ್ತಾರೆ ಅದಕ್ಕೆ? molar concentration of ion ಅಂತ ಅರ್ಥ. I have written symbol of the ion in square bracket. ಸ್ಕ್ವೇರ್ ಬ್ರಾಕೆಟ್ ಅಲ್ಲೇ ಬರೀಬೇಕು. ಯಾವುದೇ ಸಿಂಬಲ್ ಅನ್ನು ಸ್ಕ್ವೇರ್ ಬ್ರಾಕೆಟ್ ಅಲ್ಲಿ ಬರೆದಿರೋದು molar concentration of ion ಅಂತ. ಈಗ ನೋಡಿ, E naught of copper minus E naught of zinc is what? E naught of cell. ಹೌದಲ್ವಾ? ಮೈನಸ್ RT by 2F. ಹೌದಾ? And of course log to the base E of S, log A minus log B ಅಂದ್ರೆ log A by B. ಹೌದಾ? concentration of Zn plus 2 divided by concentration of S, it is copper plus 2. This is what we call it as yes, it is expression for E of cell. ಹೌದಾ? ಇಲ್ಲಿ ನೋಡಿ, ಈ ಎಕ್ಸ್ಪ್ರೆಷನ್ ಅಲ್ಲಿ ಕಾನ್ಸಂಟ್ರೇಷನ್ ಆಫ್ Zn plus 2 ಅಂದ್ರೆ ಏನು? This is concentration of product. ಇದು concentration of copper plus 2 ಅಂದ್ರೆ ಏನು? That is concentration of reactant. Therefore, in general, what I can write? E of cell is equal to yes, E naught of cell minus, okay na, RT by NF ಅಂತ ಬರ್ತೀನಿ. ಈಗ ಜನರಲ್ ಆಗಿ 2 ಯಾಕೆ ಬರ್ತಿದೆ? ಇಲ್ಲಿ ಪ್ಲಸ್ 2 ಇರೋದ್ರಿಂದ. ಹೌದಾ? log to the base E of S, Zn plus 2 ಅಂದ್ರೆ concentration of product divided by concentration of reactant. Yes, and this is what we call it as the expression for the cell potential. Nernst equation for, yes, it is cell potential. Yes, this is the expression for cell potential for a given cell, for a given galvanic cell. And of course, by knowing E naught of cell, temperature, concentration of product, ion in the product, concentration of ion in the reactant, you can determine the cell potential. ಹೌದಾನೆ? ಹೌದಾ? ಹಾಗಾದ್ರೆ look at the general equation. Yes, M1 solid plus M2 plus N, and of course ion solution, and that gives M1 plus N plus, and this is M2 solid ಅಂತ ತಗೊಂಡ್ರೆ ಇದು aqueous. Yes, ಈ ಈಕ್ವೇಶನ್ ಗೆ ಎಸ್ M1 plus N, ಈ ಈಕ್ವೇಶನ್ ಗೆ ನರ್ಸ್ಟ್ ಈಕ್ವೇಶನ್ ಬರೆದಾದ್ರೆ E of cell is equal to E naught of cell minus, ಹೌದಾ, minus RT by NF log to the base E of product ಯಾವುದು, and that is M plus N. product ತಾನೆ, M1 plus N product ತಾನೆ, ಅದು product divided by reactant, and of course M2 plus N. ಇಲ್ಲಿ ಇದು ರಿಯಾಕ್ಟೆಂಟ್, ಬಟ್ M1 ಸಾಲಿಡ್ ತಗೊಳ್ಳಲ್ಲ ನಾವು. ಯಾಕೆ ಹೇಳಿ? the molar concentration of solids will be 1. ಇಲ್ಲೂ M2 ಸಾಲಿಡ್ ಇದೆ ರಿಯಾಕ್ಟ್ ಪ್ರಾಡಕ್ಟ್ ಅಲ್ಲಿ, ಅದನ್ನು ತಗೊಳ್ಳಲ್ಲ, ಬಿಕಾಸ್ molar concentration of solid is 1. ಹಾಗಾಗಿ molar concentration of ion product in molar concentration of ion in the product side divided by molar concentration of ion in the reactant side. ಹೌದಾ? so that is, ಅಥವಾ ಈಗ ನೋಡಿ ಇನ್ನೊಂದು ರೀತಿ ಬರೀಬಹುದು ಬೇಕಾದ್ರೆ, ರೈಟ್? that is for the reaction of this type, A times A plus B times B gives C times C plus D times D. ಹೀಗಿದ್ರೆ that is E of cell is equal to E naught of cell minus, ಹೌದಾ, RT by NF log to the base E of molar concentration of products C into D, products, product of molar concentration of products divided by product of molar concentration of reactants. ಹೌದಾ? ಹೌದಲ್ವಾ? and of course C to the power is C, D to the power of D, A to the power of A, B to the power of B. ಪವರ್ಸ್ ಇದೆ ಇಲ್ಲಿ, ಹಾಗಾಗಿ ಇಲ್ಲಿ ಕೋಎಫಿಷಿಯಂಟ್ಸ್ ಇದೆ A B C D ಅಂತ, ಅದಕ್ಕೋಸ್ಕರ ಕೋಎಫಿಷಿಯಂಟ್ಸ್ ವಿಲ್ ಬಿಕಮ್ ಪವರ್ಸ್. ಫಸ್ಟ್ ಪೀಸಲ್ಲಿ ಈಕ್ವಿಲಿಬ್ರಿಯಂ ಅಲ್ಲಿ ಓದಿದಿಲ್ಲ ಆ ತರ. ಇಲ್ಲಿ ಕೋಎಫಿಷಿಯಂಟ್ಸ್ 1 1 ಇದೆ, ಹಾಗಾಗಿ ನಾವು ಪವರ್ಸ್ ಅನ್ನು ಬರೆದಿದ್ದಿಲ್ಲ ಇಲ್ಲಿ. ಹೌದಾ? ಇಲ್ಲಿ ಕೋಎಫಿಷಿಯಂಟ್ಸ್ A B C D ಇದೆ, they are not equal to 1. therefore concentration of C to the power C, concentration of D to the power D, molar concentration of A to the power of A, molar concentration of B to the power of B. This is what we call Nernst equation. ಅಥವಾ E of cell is equal to E naught of cell minus 2.303 RT divided by NF. N is the total number of electrons exchanged, log to the base 10. ಈಗ 2.303 ಬರೆದ್ರಿಂದ base 10 ಆಯ್ತು. That is equal to C to the power of C d to the power of d divided by ಹೇಳಿ a to the power of a and of course b to the power of b. This is what we call Nernst equation for acids for the reaction a times a plus b times b to give c times c and d times d. This is Nernst equation. Yes. ಅರ್ಥ ಆಯ್ತಾ? ಎಸ್, ಅರ್ಥ ಆಯ್ತಾನೆ. ಸೊ ಹಾಗಾಗಿ ಒಂದು ಎಕ್ಸಾಂಪಲ್ ಕೊಡ್ತೀನಿ ನಿಮಗೆ. ಹೌ ಟು ರೈಟ್ ದ ಎಕ್ಸ್ಪ್ರೆಷನ್ ಫಾರ್ ದಿ Nernst equation ಅಂತ ಹೇಳಿ ಒಂದು ಎಕ್ಸಾಂಪಲ್ ಕೊಡ್ತೀನಿ ನೋಡಿ. ಇದನ್ನ ರಿಯಾಕ್ಷನ್ ಎಸ್ ಯಾವ್ದಪ್ಪ ಅಂದ್ರೆ ದಟ್ ಈಸ್ ನಿಕೆಲ್ reacts with Ag plus to form nickel plus 2 plus Ag ಅಂತ ಇಟ್ಕೊಳ್ಳಿ. ಹೌದಾ? ಇಲ್ಲಿ ಪ್ಲಸ್ 2 ಇದೆ, ಪ್ಲಸ್ ಅದಕ್ಕೋಸ್ಕರ 2 ಇಂದ ಮಲ್ಟಿಪ್ಲೈ ಮಾಡಿ, ಇದು 2 ಇಂದ ಮಲ್ಟಿಪ್ಲೈ ಮಾಡಬೇಕು. ಇದು ಸೆಲ್ ರಿಯಾಕ್ಷನ್. ಈ ಸೆಲ್ ರಿಯಾಕ್ಷನ್ಗೆ ನಾನು ಏನು ಬರೀಬೇಕೀಗ? Nernst equation ಬರೀಬೇಕು. E of cell is equal to E naught of cell minus E of cell is equal to E naught of cell minus 2.303 RT by N. Total number of electrons lost ಎಷ್ಟು? Ag plus will take up 1 electron become Ag. ಆದರೆ ಇಲ್ಲಿ ಎಷ್ಟಿದೆ ಚಾರ್ಜಸ್? plus 1 into 2 2 ಆಗುತ್ತೆ. 1 Ag plus will take up 1 electron, but 2 Ag plus will take up 2 electrons. Number of electrons will be taken by silver ion is 2. Number of electrons lost by nickel also 2. Therefore it is 2F. This is 2F. N is equal to 2. Log to the base 10 of concentration of products. ಹೌದಾ? molar concentration of products. ಯಾವ್ದು ಪ್ರಾಡಕ್ಟ್ ಯಾವುದು? Ni plus 2. ಹೌದಾ? into concentration of Ag ಏನದು? 1 ತಾನೆ, because it's a solid. ಹೌದಾ? ions concentration ಮಾತ್ರ ತಗೋಬೇಕು. divided by reactant ಯಾವುದು? Ni ಏನದು? solid ತಾನೆ, ಅದು ಪ್ಯೂ ಫಾರ್ಮ್ ತಾನೆ, ಸಾಲಿಡ್ ತಾನೆ. ಹಾಗಾಗಿ ಇಟ್ಸ್ ಕಾನ್ಸಂಟ್ರೇಷನ್ ಇಸ್ 1. ಆಮೇಲೆ ಅಯಾನ್ ಯಾವುದು? Ag ಪ್ಲಸ್. ಹೌದಾ? Ag ಪ್ಲಸ್ ಗೆ ಕೋಎಫಿಷಿಯಂಟ್ ಎಷ್ಟು? 2 ಇದೆ. Ag ಪ್ಲಸ್ ಹೋಲ್ ಸ್ಕ್ವೇರ್. ಸೊ ದಟ್ ಈಸ್ ದಿಸ್ ಇಸ್ ವಾಟ್ ವಿ ಕಾಲ್ Nernst expression for Nernst equation for this particular cell reaction. ಹೌದಾ? ನೀವು ಕಾನ್ಸಂಟ್ರೇಷನ್ ಆಫ್ ಅಯಾನ್ಸ್ ಮಾತ್ರ ತಗೋಬೇಕು. ಅಕಸ್ಮಾತ್ ಅಲ್ಲಿ ನ್ಯೂಟ್ರಲ್ ಪಾರ್ಟಿಕಲ್ಸ್ ಅಥವಾ ಸಾಲಿಡ್ ಪಾರ್ಟಿಕಲ್ಸ್ ಇದ್ರೆ ಮೋಲಾರ್ ಕಾನ್ಸಂಟ್ರೇಷನ್ ಆಫ್ ಸಾಲಿಡ್ಸ್ ವಿಲ್ ಬಿ ಟೇಕನ್ ಆಸ್ 1. ಹಾಗಾಗಿ ನಾವು ಬರೀ ಕಾನ್ಸಂಟ್ರೇಷನ್ ಆಫ್ ಅಯಾನ್ಸ್ ತಗೋಬೇಕು. ಅರ್ಥ ಆಯ್ತಾ? ಸೊ ದಿಸ್ ಇಸ್ ವಾಟ್ ವಿ ಕಾಲ್ ಇಟ್ ಆಸ್ Nernst equation for this reaction. ಎಸ್, ನೀವು ಬೇಕಾದ್ರೆ ಇದನ್ನ ಹೀಗೆ ಬರೀಬಹುದು. ಅಟ್ 298 ಕೆಲ್ವಿನ್ಸ್ ಏನ್ ಬರೀಬಹುದು? E of cell is equal to E naught of cell minus ಇದೆಲ್ಲ ಸೇರಿಸಿದ್ರೆ ಆಗುತ್ತೆ 0.0591 divided by yes it is N. ಅವಾಗ ನೋಡಿದ್ರಲ್ಲ, then log to the base 10 of concentration of C to the power of D, D to the power of D divided by concentration of A to the power of A, concentration of B to the power of B. This is also expression for Nernst equation, that is cell potential. ಹೌದಾ? and of course at 298 kelvins. ಹೌದು ತಾನೆ? yes, ಆಗ್ಬೋದಾ? I'll go for the one of the applications of this particular Nernst equation, that is relationship between E naught of cell and equilibrium constant. Yes, relationship between S E naught of cell, standard cell potential, and equilibrium constant. KC ಅಂತ ಕರಿತೀವಿ. ಹೌದಾ? ದಿಸ್ ರಿಲೇಶನ್ಶಿಪ್ ಟು ಬಿ ಡಿಸ್ಕಸ್. ಇದ್ರ ಮೇಲೆ ಪ್ರಾಬ್ಲಮ್ಸ್ ಕೇಳ್ತಾರೆ. ಎಸ್, ಫಾರ್ ದ ರಿಯಾಕ್ಷನ್ A times A plus B times B gives C times C plus D times D. ಇದು ಒಂದು ಸೆಲ್ ರಿಯಾಕ್ಷನ್ ತಗೊಂಡ್ರೆ E of cell is equal to E naught of cell minus, ಹೌದಾ? yes, 0.059 divided by N log to the base 10 of, ನಾನು ಆ 298 ಕೆಲ್ವಿನ್ಸ್ಗೆ ಬಂದ್ಬಿಡ್ತೀನಿ. ರೈಟ್? ಓಕೆ, ಇಲ್ಲ ಅಂದ್ರೆ ಈಗ ಮಾಡಿ ಬೇಕಾರೆ. ದಟ್ ಈಸ್ 2.303 RT by NF log to the base 10 of, ಹೇಳಿ, ಪ್ರಾಡಕ್ಟ್ C to the power of C, D to the power of D, products divided by reactants A to the power of A into B to the power of B. This is the, as it is, Nernst equation. As chemical reaction proceeds, that is in the galvanic cell, chemical reaction is spontaneous. As the chemical reaction proceeds, concentration of C and D increases. ಹೌದಾ? ಕಾನ್ಸಂಟ್ರೇಷನ್ ಆಫ್ C and D ಜಾಸ್ತಿ ಆದ್ರೆ ಟೋಟಲ್ ಈ ವ್ಯಾಲ್ಯೂ ಜಾಸ್ತಿ ಆಗುತ್ತೆ. ಹೌದಲ್ವಾ? ಈ ವ್ಯಾಲ್ಯೂ ಜಾಸ್ತಿ ಆದ್ರೆ E of cell decreases. ಹೌದಾ? ಹೌದಲ್ವಾ? ಈಗ X is equal to A minus B ಅಂದ್ರೆ as B value increases X value decreases. ಹೌದು ತಾನೆ? as B value increases X value decreases. ಹಂಗೆ As concentration of C and D increases, the whole this value increases, E of cell decreases. Therefore, at equilibrium, yes, reaction proceed agate enagate equilibrium reach agate. The concentration of C end will be highest, concentration of A end will be lowest. Aga this value will be very very high, then E of cell becomes equal to 0. E of cell becomes equal to 0. At equilibrium, this ratio C to the power of C, D to the power of D divided by A to the power of A into B to the power of B, this ratio is taken as equilibrium constant Kc, and this is only at equilibrium when E of cell is equal to 0. Even substitute party, 0 is equal to E naught of cell minus 2.303 RT by, yes it is NF log to the base 10 of Kc. ಹೌದಾ ಈ ವ್ಯಾಲ್ಯೂ ಬದಲು ಏನು ಬರ್ತೀನಿ ನಾನೀಗ Kc ಅಂತ ಬರ್ತೀನಿ. ಹೌದಾ ವಾಟ್ ಇಟ್ ಇಂಪ್ಲೈಸ್ E naught of cell is equal to 2.303 RT by, yes it is NF log to the base 10 of, yes it is Kc. This is what we call it as relationship between standard cell potential and equilibrium constant. This is temperature, gas constant, Faraday's constant, and N is number of electrons lost or gained. Total number of electrons lost will be equal to total number of electrons gained. Agagi, so this is what we call it as relationship between E naught of cell and equilibrium constant Kc. Agboda? Yes. ಇದೇ ಕಾನ್ಸೆಪ್ಟ್ ಅನ್ನ ನಾನು ಏನ್ ಮಾಡ್ತೀನಿ ಈಗ, ಐ ಆಮ್ ಗೋಯಿಂಗ್ ಟು ಅಪ್ಲೈ ದಿಸ್ ಸೇಮ್ ಕಾನ್ಸೆಪ್ಟ್ ಟು ದಿ ಡೇನಿಯಲ್ ಸೆಲ್. ಡೇನಿಯಲ್ ಸೆಲ್ ಅಪ್ಲೈ ಮಾಡಿ ಒಂದು ಕನ್ಕ್ಲೂಷನ್ ಮಾಡಿದ್ದಾರೆ, ಅದಕ್ಕೋಸ್ಕರ ಅದನ್ನ ನಾನು ಡಿಸ್ಕಸ್ ಮಾಡ್ತಿದ್ದೀನಿ. ಎಸ್, ಫಾರ್ ಡೇನಿಯಲ್ ಸೆಲ್ ಏನು Zn and that is plus Cu plus 2, that gives what? Zn plus 2 plus, yes it is Cu. ಹೌದಾ? ಇಲ್ಲಿ N is equal to 2 ಹಾಕಬೇಕು. ಹೌದಾ? Because number of electrons will be lost will be 2. Temperature 298 kelvins ತಗೊಂಡ್ರೆ ಏನಾಗುತ್ತೆ ನೋಡಿ. And of course for standard cell potential for Nernst equation E naught of cell as you calculated 1.10 volt. ಹೌದು ತಾನೆ? ಸಬ್ಸ್ಟಿಟ್ಯೂಟ್ ಮಾಡಿ ಈಗ. E naught of cell ಬದಲಾಗಿ 1.10, that's equal to, yes it is temperature 298 kelvins ಹಾಕ್ಬಿಟ್ರೆ ವ್ಯಾಲ್ಯೂ ಏನಾಗುತ್ತೆ 0.059 divided by 2. ಹೌದಾ? Because N is equal to 2 here, and of course log to the base 10 of, yes, and that is what we call it as Kc. ಹೌದು ತಾನೆ? Of course log to the base 10 of Kc. ಹೌದಾ? ಈಗ you need to find out that value of Kc now. Yes, you need to find out the value of Kc. Therefore log to the base 10 of Kc equals 2 into, yes it is 2 into 1.10 divided by 0.059, that's equal to, yes, ಅದನ್ನ ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡಿದ್ರೆ ನೋಡಿ 2 into, yes 2 into 1.1 divided by 0.059, yes, comes out to be 37.288, that is 37.288. yes. ಈಗ I want Kc there, is it not? I want Kc here. ಹೌದಾ? ಏನಾಗುತ್ತೆ ಈಗ log Kc is equal to 37.28. Therefore Kc is equal to anti-log of, yes it is 37.288. yes, or you can say anti-log of, yes it is 37 plus 0.288 ಅಂತ ಬರ್ಕೋಬಹುದು. ಹೌದಲ್ವಾ? 37.288 ಅನ್ನ 37 plus 0.288 ಅಂತ ಬರ್ಕೊಂಡಿದ್ವಿ. Anti-log of 37 is 10 to the power of 37. yes, ಇಲ್ಲಿ ಪ್ಲಸ್ ಇರೋದ್ರಿಂದ ಇಂಟು ಹಾಕಬೇಕು. ಓಕೆ, anti-log of a plus b is equal to, yes it is equal to a into b ಆಗುತ್ತೆ. yes, ಓಕೆನಾ? Anti-log of 37 is log 10 to the power of 37. Anti-log of 0.28 is, it is approximately equal to 2 there, and of course therefore Kc is equal to 2 into 10 to the power of 37. That Kc is equal to what? 2 into 10 to the power of 37 as far as Daniel cell is concerned. Anti-log of, yes it is 0.28 ಅನ್ನ 2 ಅಂತ ಯಾಕೆ ಬರ್ತೀವಿ ಅಂತಂದ್ರೆ ನಿಮಗೆ ಗೊತ್ತಿದೆ log to the base 10 of 2 is equal to 0.3010. ಇದು ಗೊತ್ತಾದ base 10 of 2 is 0.3010. Therefore anti-log of 0.3010 is equal to 2. They are inverse to each other. ಓಕೆನಾ? log 2 0.30 ಆದ್ರೆ anti-log of 0.3 ಎಷ್ಟಾಗುತ್ತೆ 2 ಆಗುತ್ತೆ. ಅದು ಕಾನ್ಸೆಪ್ಟ್. ಹಾಗಾಗಿ ಆಂಟಿಲಾಗ್ ಆಫ್ 0.3 ಎಷ್ಟು 2 ಆದ್ರೆ ಆಂಟಿಲಾಗ್ ಆಫ್ 0.28 ವೆರಿ ಕ್ಲೋಸ್ ಟು 0.3 ಅಲ್ವಾ, ಹಾಗಾಗಿ ನಾನು 2 ಬರ್ದಿದ್ದೀನಿ. 2 × 10⁻37. ಇನ್ನು ಬರೋ ಕಾಂಪಿಟೇಟಿವ್ ಎಕ್ಸಾಮ್ಸ್ ಡಿಸ್ಕಸ್ ಮಾಡಬೇಕು, ಅದ್ರ ಬಗ್ಗೆ ಹೇಳ್ತೀನಿ ನಿಮಗೆ ಐಡಿಯಾನ. ಓಕೆನಾ? ಸೊ ದಿಸ್ ಇಸ್ ವಾಟ್ ವಿ ಕಾಲ್ ಇಟ್ as KC value for Daniell cell. Yes, so this is what we call relationship between E naught of cell and yes, it is equilibrium constant. Now at this moment, yes, E naught of cell and delta G naught standard free energy change. That is whenever free energy, that is related to the amount of work done during a particular reaction. That is amount of energy available for doing useful work is called free energy. ಹೌದಾ? ಥರ್ಮೋಡೈನಮಿಕ್ಸ್ ಹೇಳ್ಬೇಕಾದ್ರೆ ಅದ್ರ ಬಗ್ಗೆ ಡಿಸ್ಕಸ್ ಮಾಡೋಣ. ಅಮೌಂಟ್ ಆಫ್ ಎನರ್ಜಿ ಅವೈಲಬಲ್ ಫಾರ್ ಡೂಯಿಂಗ್ ಯೂಸ್ಫುಲ್ ವರ್ಕ್, ದಟ್ ಇಸ್ ಕಾಲ್ಡ್ as free energy. ಹೌದಾ? Whenever useful work done, free energy decreases. That is, for useful work done, delta G naught is equal to negative for spontaneous process, because in spontaneous processes useful work will be done. In the case of electrochemical cells, in the case of galvanic cells, that production of electricity, during production of electric current, ಏನಾಗುತ್ತೆ, certain amount of useful work will be done. Amount of work done W is equal to, that is quantity of electricity produced, that is given by NF. This is the quantity of electricity produced, that is total amount of electricity produced into, yes, it is the cell potential, that is E naught of cell. This is what we call amount of work done. ಯಾವುದೇ ಒಂದು ಪ್ರಾಸೆಸ್ ಅಲ್ಲಿ, ಯಾವುದೇ ಒಂದು ಸ್ಪಾಂಟೇನಿಯಸ್ ಪ್ರಾಸೆಸ್ ಅಲ್ಲಿ ಏನಾಗುತ್ತೆ ಅಂದ್ರೆ certain amount of useful work will be done. Whenever useful work done, ಏನಾಗುತ್ತೆ, free energy decreases, means delta G naught is negative. Whenever useful work is done, delta G naught, that is negative, because whenever useful work done, free energy decreases, therefore delta G naught is negative. Therefore delta G naught is equal to minus NF, yes, it is E naught of cell, minus NF E naught of cell, that is standard free energy. Andre by knowing cell potential, standard cell potential, you can determine standard free energy change. ಈಗ ನೋಡಿ, if delta G naught is negative, E naught of cell is positive. ಹೌದಲ್ವಾ? delta G naught negative ಅಂದ್ರೆ E naught of cell positive. ಅಂದ್ರೆ during spontaneous process delta G naught is negative, means E naught of cell is a positive for spontaneous reaction that is going on in, yes, it is galvanic cells. And of course E naught of cell is equal to, ನಿಮಗೆ ಗೊತ್ತಿದೆ, 2.303 RT by NF log to the base 10 of, yes, it is equilibrium constant. ಇದು ಗೊತ್ತಲ್ಲ ನಿಮಗೆ? ಈ ವ್ಯಾಲ್ಯೂ ಸಬ್ಸ್ಟಿಟ್ಯೂಟ್ ಮಾಡಿದ್ರೆ ಏನಾಗುತ್ತೆ, delta G naught equals minus NF into E naught ಬದಲಾಗಿ ಏನಾಗ್ತೀರಾ, 2.303 RT by NF log to the base 10 of, yes, it is equilibrium constant KC. NF get cancelled. ಹೌದಾ? ಹಾಗೇನಾಗುತ್ತೆ, so it is delta G naught equals minus 2.303 RT log to the base 10 of KC. This is the relationship between equilibrium constant and of course standard free energy change. When standard free energy change is negative, ಏನಾಗುತ್ತೆ, equilibrium constant will be positive. As equilibrium constant becomes more and increases, delta G naught becomes negative. Andre during spontaneous process delta G naught is negative, then equilibrium constant will be high. Andre reaction proceeds more in the forward direction anta artha. If equilibrium delta G naught is positive ಆಗ್ಬಿಟ್ರೆ, if delta G naught becomes positive, ಏನಾಗುತ್ತೆ, KC becomes negative. delta G naught positive ಆಗುತ್ತೆ non spontaneous process. In non spontaneous process equilibrium will not be shifted in the forward direction, rather it will be in the backward direction. ಹಾಗಾಗಿ if KC is negative, equilibrium is shifted in backward direction and it is a non spontaneous process. ಈ ಎಲ್ಲ ಡಿಸಿಷನ್ಸ್ ಅನ್ನು ನಾವು ಈ ರಿಲೇಶನ್ಶಿಪ್ ಮೂಲಕ ತಗೋಬಹುದು. ಇದನ್ನ ಫಸ್ಟ್ ಪೀಸ್ ಅಲ್ಲಿ ಕೂಡ ನೀವು ಓದಿದ್ದೀರಾ. ಓಕೆನಾ? ಸೊ ದಟ್ಸ್ ಆಲ್ ಅಬೌಟ್ ಸ್ಟ್ಯಾಂಡರ್ಡ್ ಸೆಲ್ ಪೊಟೆನ್ಷಿಯಲ್. ಓಕೆನಾ? ಸ್ಟ್ಯಾಂಡರ್ಡ್ Nernst equation for cell potential and electrode potential. ಹೌದಾ? Then it is relationship between cell potential and standard free energy change, relationship between equilibrium constant and standard cell potential. We discussed all these things. I hope you got my point. Okay na? In the next video we solve the problems on this particular aspect. Agboda? Thank you. Right?